recall, if we integrate x to the 4 dx, we add 1 to the 4 and get 5, and so we multiply by the reciprocal plus c. Okay? If f of x equals ln of x, where we know x must be greater than 0, we know f prime of x equals 1 over x. Okay? So let's integrate now. Integrate 1 over x dx. Well, if x is greater than 0, we know it's just going to be ln x plus c. But that's if x is greater than 0. If it hasn't been established that x is greater than 0, then we would say the answer is ln absolute value of x plus c. Okay, so let's do another type of problem. Recall if y equals e to the 3x, then y prime is e to the 3x times the derivative of 3x, which is 3. Okay, so now let's integrate 3e to the 3x dx. Okay, well, we know there's going to be a 3, that stays there. We know that e to the 3x will stay there. And we have to ask ourselves, how can we get back to here with what we have here? Well, we have to multiply by 1 over 3 plus c. 3 times 1 over 3 is just 1, so that's e to the 3x plus c. So let's do another example. We're going to integrate 8e to the 3x dx. Okay, so we're going to keep the 8 there. We have e to the 3x. We're going to multiply by 1/3 plus c, and we end up with 8/3 e to the 3x plus c. Okay, we have some integration properties. So I'm going to write those and do some examples. Okay, so integration properties. Integration properties. Again, I hope you're taking your own notes. It'll go into your brain better if you take your notes versus just taking pictures of what I'm doing. So if we integrate k times f of the x dx, the property states that we can take the k, which is a constant, outside the integral f of x dx. So k is a constant. Here's an example. If we integrate 3x squared dx, using the property, we can bring out the 3x squared dx, and then we can go ahead and integrate this. So we leave the 3 alone, and we multiply the integration of this. We add 1 to the 2 times 1/3 plus c, which equals x cubed plus c, because this is multiplying. Okay? All right, so the next property, if we integrate f of x plus g of x dx, the property states that we can integrate f of x plus the integration of g of x. And we need d of x's in there. All right, so here's an example. This is going to take a lot of space. I don't know if I'll get it all on this one board. We're going to integrate 3x to the 4th plus 6x squared. Take away 2x plus 8 dx. Okay, we're going to use this property and split them all up. So we're integrating 3x to the 4th dx plus the integration of 6x squared dx minus the integration of 2x dx plus integration of 8 dx. Okay, so now from here we're going to use the same property as we did over here. We have constants, we can bring them out. So I'm going to bring this constant out. Integration of x to the 4th dx. Make sure this looks like an integral. Okay. Bring this 6 out because it's a constant. Bring this 2 out. And then that 8 will just stay there. Okay. Now from here we're going to integrate each individual one. So I'm going to try to get this in here instead of erasing it so you can see. Alright, we're going to keep this 3 here. Add 1 to 4, we get 5. And we multiply by 1/5. Okay. Next one, keep the 6 there. We're going to add 1 to the 2 and multiply by 1/3. Next one, keep the -2 there. Add 1 and multiply by 1/2. Then the last one, plus 8x. All right. Now, am I forgetting something? Yes, I am. You're right. I'm forgetting a plus c. Don't forget that plus c when you have an indefinite integral. Okay, from here, we're just going to put the 3 over the 5. 6 divided by 3 is 2. This turns out to -1, and so forth. Okay. Okay, so to conclude on that problem, we'd have 3/5 x to the 5th plus 2x cubed minus x squared plus 8x plus c. Okay, let's keep going. Let's do another problem, but we're going to be a little quicker on it by taking some shortcuts. Now that you've seen the process, we can do it a little quicker. Okay, so we're integrating 5x cubed plus 4x squared plus 3x. So immediately we're going to put out the 5, the 4, and the 3. Okay, now the next step is where we're going to take a shortcut. We're going to add 1 here so we get a 4. We know we're going to divide by a 4, and we have a 5, so it's 5/4. Okay? Next one, we're going to add 1 to the 3, 1 to 2, which gives us 3. So we're going to divide by 3, and this multiplies by our 4. Okay? Here we have an x to the 1 power. We're going to add 1, which gives us x squared. Divide by 2, and we bring our 3 plus c. Isn't that a lot easier? Okay, let's do another example. Okay, we're going to let x be greater than 0. And we're going to integrate 2 over x plus 4 over x cubed minus 3 over x to the 5th. All of that to dx. Okay, so if we want, we can pull out all the whole numbers. We have 2 integrating 1 over x dx plus 4 integrating 1 over x cubed dx minus 3 integrating 1 over x to the 5th dx. Okay, so to integrate, remember 1 over x is different from what we do with everything else. Remember, the integration of this is ln of x. We were told x is greater than 0, so we're going to keep that 2, and the integral of 1 over x is ln of x. Okay, for the next one, I'm going to change these, bring them up so we have negative exponents. It's easier to work with it that way. Okay, so negative exponents. bring down 2 ln of x. Okay, we're going to keep this 4. Negative exponent, we're going to add 1 to a negative 3. That gives us negative 2. So we're going to multiply by 1 over negative 2. Okay, next one we keep this negative 3. We're going to add 1 to the negative 5. That gives us negative 4. So we're going to multiply by 1 over negative 4. And then what do we need to do? That's right, plus c. Okay, so let's simplify this now. 2 ln of x minus 2 x to the negative 2 plus 3/4 x to the negative 4th plus c. And if we want to continue, we can get rid of those negative variables by putting them in the denominator, positive. Okay, keep going. X to the 4th plus c. All right. So now I'm going to do some WebAssign hints. That's basically the lecture. But these WebAssign hints are really necessary. Otherwise you'd be going, Professor, I don't understand how to do this problem. So I'm going to get you started on the problem. Okay, so for WebAssign, all right, we're going to look at number 10 and 11. So these are hints for number 10 and 11. Okay, so recall the distance function if the distance function equals s of t, then remember s prime of t equals v of t, and remember v of t is the velocity. My pen's dying here. Okay, so then if we take double prime t, that'll be v prime t, and that equals a of t, which is acceleration. Okay, so here's an example of what we're working with. If they give you something like this, say if a of t equals 6t, if a of t equals 6t, and v of 0 equals 5, and s of 0 equals 12, the problem will be find s of t. Okay, my pen's not working quite well here. I'm going to go to something a little lighter in color. Hopefully you'll be able to see it. Okay, so what do we know? What have they told us so far? We know s of 0 is 12. We know v of 0 is 5. If f of 0 is 12 and v of 0 is 5, and we know s prime of t is v prime of t, we can conclude that s prime of 0 equals 5. Okay, so we're going backwards now. All right, now a of t equals s double prime of t, which is 6t, because it's stated a of t is 6t, and we know s double prime of t is a of t. Okay. All right, so if we know s double prime of t is 6t, s prime of t is going to be the integral of 6t dt. Okay, so let's integrate that. That's 6 integral, oops, sorry about that. I'm going to bring out the 6, integrate t dt, and that equals 6. We'll keep the 6 there. We add 1, and we get t squared times by 1/2. Okay, and then of course plus c. So So our answer would be 3t squared plus c. All right? Now that's s prime of t. But what do we have here? S prime of 0 is 5. So s prime of 0, we're going to put a 0 in here, and we get 3 squared plus c, which is c. But what do we know here? S prime of 0 is 5. So 5 equals c. Okay, so we're going to use that to continue on this problem. So what we can conclude is s prime of t equals 3t squared plus 5. Okay, you may have to see that again and do it again. Okay, we're going to keep using what we found here to continue on the problem for WebAssign. All right, so s prime of t is 3t squared plus 5. Okay, so s of t now, we know, is the integral of 3t squared plus 5 dt. See what we're doing? Okay, so let's integrate this. This equals, we'll keep the 3, we'll add 1 to that 2, multiply by 1/3. Integrate 5 is 5t plus c. So simplifying this, we have t cubed plus 5t plus c. Looks like I'm writing with watercolor, doesn't it? It's really weird. Okay, what do we know about s of 0? They told us s is 0. If we put a 0 in there, we're going to get 0 cubed plus 5 times 0 plus c. But what did they tell us? They told us earlier s of 0 equals 12. So here, if s of 0 equals 12, then what does that tell us? C must equal 12. Okay, so in answer to the question, s of t is going to equal t cubed, right here, plus 5t, and what is our c? Plus 12. Ta-da! There's our answer. Okay, I'm going to give you a couple more hints for the homework, and that is for number 12, A, v of t is given. So s of t is going to equal the integral of v of t. That's kind of what we just worked with. Okay, for B, they're giving us 88 feet per second equals v of t. Okay, so what you need to do is solve for t, and then put that answer into s of t to find the distance. Now this will make all sense when you're actually doing your work. Okay, 2 more things. Number 13, see example 12 in the book. And for 14, see example 13. Okay.